One of the amazing things here at Puma Punku is the precision of the blocks. You can see with this block of music granite that it's really being cut at very accurate right angles. Imagine finding stones lying on the ground between mountains at an altitude of nearly 13,000 feet at first glance. They don't look like broken pieces of an ancient building, but more like parts of a large machine. The H-shaped blocks at Puma Punku in Bolivia remain a similar mystery even today. Looking at their rectangular cuts, sharp right angles, and identical grooves, the first question that comes to mind is how were such hard stones cut so cleanly? But the real surprise is not their shape. It is their precision. On hard stones like andite and diorite, some surfaces appear so flat that they remind you of machine-made parts. And when the measurements of these blocks were examined closely using modern laser scans and geometry analysis, the mystery became even deeper. Instead of giving AI old theories about these stones, it was given only the measurements and asked one simple question. What do you see in these numbers? After this, from the H-blocks to small drill holes and repeatedly used measurements, certain patterns were said to have appeared that raised a new question. Are we simply looking at incredible ancient craftsmanship, or have these stones preserved signs of a technique that we still do not fully understand today? What exactly did AI see that left experts surprised? Before we go into the details, please subscribe to the channel. Puma Punku is part of the Tiwanaku complex in Bolivia's Altiplano region. This place sits at a very high altitude, and the surrounding area has extremely harsh weather. According to the common archaeological explanation, it is connected to the Tiwanaku culture, which was a strong and organized society in this region around 1,500 years ago. The Tiwanaku people were not ordinary. They built raised fields and terrace systems for farming at such a high altitude, developed ways to manage water, and also showed the ability to organize large numbers of people to work together. So, it would be wrong to assume that they had no engineering knowledge. According to the mainstream explanation, Puma Punku's large stones were brought from distant quarries. They may have been pulled to the site using ropes, ramps, and human strength. Stone hammers, copper tools, sand, and other abrasives may have been used to shape the stones. This work would not have been quick. It would have required a lot of time, skilled workers, and continuous effort. When you look at it this way, this explanation does not seem impossible on its own. Ancient civilizations completed many large construction projects without modern machines. So, just because of the size or weight of these stones, it would not be right to say that the Tiwanaku people could not have done it. But the real question of Puma does not begin with how the stones were brought here. The real question begins when their cuts, grooves, right angles, and repeatedly used measurements are examined very closely. Now, let's come to Puma Punku's H-shaped blocks, which are among the most surprising things at this entire site. Today, these stones are scattered across different parts of the ground. Despite centuries of weather, earthquakes, and other disturbances, their shapes and internal patterns can still be compared with one another. At first glance, these H-blocks simply look similar, but the real detail appears when their measurements are examined carefully. Each block has recessed rectangles on the inside. Their internal right angles, groove depths, and overall block proportions show a particular kind of repetition. When different blocks were scanned and compared, the variation between them was found to be extremely small. This is where a bigger question comes up. If a craftsman makes several stones with the same design by hand, they may look almost identical from a distance. But when measured very closely, small differences are normal. Hand pressure can change, visual estimates can be slightly different, tools can slowly wear down, and fatigue can also affect the work over time. But the kind of uniformity seen in Puma Punku's H-blocks has been described as having less than a millions to one chance of being achieved through freehand carving. However, to understand such a large probability claim, it is also important to look at the measurements and how they were calculated. In modern engineering, if a workshop produces several parts and the angles, grooves, and proportions of every part remain consistently the same, that kind of repeatability is usually linked to a controlled manufacturing process. Numerically controlled machines work on the same principle. Each part is made again and again according to a fixed measurement. The most interesting thing about Puma Punku is not just that the H-blocks were beautifully cut. In many places, their tolerances appear more precise than necessary. This means the goal of the builders was not simply to create the correct shape, but also to repeat the same measurement in every piece. After the identical shape of the H-blocks, the next question is about their surfaces. The recessed surfaces inside these blocks look quite flat. Even if you run your hand over them, you may not easily feel any major bump or depression. But this is not just about what our eyes can see or our hand can feel, because our eyes and hands are not precision instruments capable of detecting extremely small differences. That is why these surfaces were also examined using laser scanning. In this process, a very large number of points are recorded across the entire stone surface. These points can then be combined to create a detailed 3D model of the stone on a computer. After that, researchers can see how far a surface rises above or falls below a perfectly flat or true plane. In these measurements, variation on some surfaces has been reported at the level of fractions of a millimeter. What is even more surprising is that this flatness does not appear limited to just one small area. Instead, there seems to be considerable consistency across the length of the surface. This is where hard stone like andesite raises another question. Making a stone flat by hand is not impossible. In ancient times, abrasive materials could be used to make stone surfaces quite smooth and flat. One method is to have an already flat reference surface. Any raised area could slowly be ground down using sand or another abrasive and repeatedly checked against the reference. This process would continue until the surface became even. But there are two problems with this. First, if you want very high accuracy, you also need an equally accurate reference plane to begin with. The question is, how was that reference created with such precision? The second problem is time. Manual grinding and lapping on a hard stone like andesite can be extremely slow. If Puma Punku had only one such surface, it could be considered the extraordinary work of a highly skilled craftsman. But several carefully finished surfaces can be seen across different blocks. So the question is no longer simply whether it could be done, but how it was done so many times and with such consistency. Drill holes, diameter, depth, and spiral marks. After the flat surfaces, the next interesting feature at Puma Punku is the small cylindrical holes found on some blocks. At first glance, they do not seem unusual. It looks like they may have been made to hold some kind of peg or fitting. But when holes from different blocks were compared, the question was no longer just why they were made, but also how they were made. Three things were especially noticed in these holes: their diameter, depth, and the light tool marks visible on the inner walls. If a hole is made in hard stone using a hand-operated drill, some variation is normal. The drill may wobble slightly while rotating. The mouth of the hole may become a little wider at the beginning. If the hand angle changes, the hole may not remain perfectly straight. Also, a person gets tired while working. So, keeping the pressure and rotation speed exactly the same for a long time can be difficult. But when several holes at Puma Punku were compared, very little variation was seen in their diameter. The difference was reported to be so small that it was even compared with holes made by an inexperienced person using a modern power drill. Similar consistency was also seen in their depth. It appears that the drill was stopped at almost the same fixed depth each time. The most interesting detail comes from the marks visible inside the holes. When a cutting edge rotates and moves forward during drilling, it can leave light spiral-like lines inside. The distance between these spiral marks is called pitch. In simple terms, how fast a drill rotates and how far it moves inward with each rotation both affect this pattern. This can be described as a relationship between feed and rotational speed. If hand pressure or rotation speed keeps changing, you would expect the spiral spacing to change as well. But in some holes, this spacing appears quite consistent. Because of this, the bore geometry has been compared to drilling with controlled feed and speed. This does not mean that the use of a modern machine has been proven. The measurements only show that the geometry and tool marks inside the holes appear highly consistent. Which tool was used, what technique was followed, and when these holes were made cannot be determined from these marks alone. So far, we have looked separately at the shape of the H-blocks, their flat surfaces, and the small drill holes. But when all these measurements were considered together, another interesting detail appeared. It seemed that the different cuts on the blocks were not unrelated. In many places, the width of a channel, the depth of a groove, and the dimensions of other sections appeared to be connected. In the same way, a pattern can also be seen in the spacing between drill holes and the proportions of the H-blocks. In some blocks, the recessed section appears to have been shaped to fit with the projection of another section. In other words, these stones do not simply look like separate sculptures made for display. They look more like parts designed to connect with one another inside a larger structure. A modern example will be prefabricated construction. Different parts of a building or machine are made according to predetermined dimensions. They are then brought to the site and assembled. For this to work, the measurements of every part must be correct, because if one piece is even slightly wrong, another may not fit properly. The blocks at Puma Punku also show geometry in many places where pieces could have interlocked, sat in position, and supported surrounding sections. Interestingly, tight fitting would not always require thick mortar layers or shims to fill the gaps. In simple terms, in many places, the fitting itself appears to do the job of finishing. So, one block being carved extremely well is not the biggest question. What matters more are the dimensional relationships that appear again and again throughout the complex. If different pieces were made according to the same system, the builders would have needed to know in advance which part would fit where and how. The environment of this place also makes the story interesting. It is a high plateau where large long trees were not easily available. Because of this, some conventional possibilities such as transporting heavy blocks on wooden sleds also raise questions. However, transporting the stones to the site and cutting them with such precision are two separate problems. Finding an answer to one does not automatically solve the other. Master measurements of Puma Punku. Now the question was whether a single basic unit would behind the different measurements at Puma Punku. In simple terms, just as today we use centime, inches, or meters as fixed measurements to decide the size of other things, a similar base value seems to appear here, repeating again and again in different places. In engineering, such a repeated basic value can be understood as a modulus. When the grooves, recessed sections, spacing between holes, and overall dimensions of the blocks were compared together, some measurements appeared to be connected. In some places, the same basic value appears directly, while in others, it appears as 2 times, 3 times, or another proportion of that value. This suggests that each craftsman was not cutting stone according to his own preference, but that a common measurement system may have been followed. This is what makes Puma Punku even more interesting. If the same basic unit was used throughout the complex, it would have needed to be passed to every worker in the same way. For this, there must have been some standard ruler, reference tool, template, or another measuring system. Planning would also have been necessary because the width of a groove, the depth of a recess, and where the next block would fit had to be decided before the work began. Today we use drawings and written measurements for this kind of planning. In the case of Puma Punku, the question is how this information was passed on to workers at that time, especially because we do not have any clear written record explaining this construction process. This difference is quite important. One highly skilled craftsman can create an impressive stone on his own, but when different workers repeatedly produce the same measurements on different blocks, it is no longer just a matter of craftsmanship. It requires an entire system in which everyone follows a common standard. And the story did not remain limited to Puma Punku. Some similar dimensional patterns can also be seen at nearby Tuanaku. This is not very surprising on its own. Both sites are close to each other and are connected to the same cultural tradition. So the use of common workshops, builders, or a shared measurement system is completely possible. The same measurement at other ancient sites. The most controversial claim. Finding a similar basic measurement at Puma Punku and nearby Tuanaku makes sense. Both places are in the same region and a cultural connection between them is also accepted. But after this, the same measurement was compared with the dimensions of other ancient sites. This is where the story becomes more interesting and at the same time more controversial. That basic unit could now be used as a kind of numerical fingerprint. In other words, researchers could look at stones, walls, blocks, and the space in between them at other megalithic sites to see whether the same number or its exact multiples appeared there as well. During these comparisons, similar values appeared at some places thousands of kilometers away from Puma Punku. These sites were built by different cultures, and accepted history shows no clear evidence of direct contact between them. Some structures are even linked to periods when writing did not exist. So seeing a similar measurement naturally raises a new question. One thing is important to understand here. Nature can create stones with unusual shapes on its own. Wind, water, and erosion can sometimes produce shapes that look man-made, but measurement is slightly different. A fixed unit is an idea. If a builder decides that every block should be twice a certain unit in width and the spacing should be 3 times that unit, then that unit has to be known, remembered, and passed on to other workers. So if 2 cultures located very far apart were truly using the same measuring module, how did that happen? One possibility could be direct contact or trade. Another could be migration, where people carry their measurement system with them to a new place. A third possibility is that both cultures received this knowledge from an older common source. And the simplest possibility is that there was no connection at all. The matching numbers could simply be a coincidence. That is why it would not be right to conclude that there was a lost global civilization based only on matching measurements. First, we need to see how close the values actually are, how often they repeat, and how likely it is for such a pattern to appear in random measurements. Because if you search through enough numbers for long enough, you will eventually find some kind of matching pattern. Coincidence test. Was AI merely searching for patterns? Now, the most important question was whether AI was finding a pattern among thousands of measurements that did not actually exist. One weakness of pattern recognition systems is that when they are given too much data, they can sometimes find connections even between random numbers. So, simply saying that measurements from different sites were matching was not enough. To test this, these values were compared with a random model. It assumed that every culture developed its own measurement unit without any outside influence. In other words, builders at one place had no knowledge of the standard used somewhere else. Researchers then looked at how likely it would be for those same measurements or their multiples to appear repeatedly in such a situation. The calculated probability of repeated matching was extremely low, so low that it was described as being close to zero. A simple example can help explain this. Imagine tossing a coin and instead of landing flat, it stands on its edge. Even once would be extremely rare. But if the same thing happened 900 times in a row, technically you could not call it completely impossible, but practically you would start asking whether something else was causing it. The question with these measurements was similar. These dimensions were shown to an engineer without telling him where they came from. At first, he thought he was looking at measurements of different parts made in the same facility according to one specification. To him, the consistency in the numbers looked like a common manufacturing standard. But when he was told that these measurements were not from one workshop, but were linked to megalithic sites on 3 different continents, the situation completely changed. This raised another possibility. Perhaps this standard did not develop independently in different places, nor did it simply spread later from one culture to another. It may have been inherited by different societies from an older source. But caution is important here. Just because a pattern is statistically very unlikely does not automatically prove that one advanced civilization once existed across the entire world. Statistics can only suggest that coincidence is becoming a weaker explanation. After that, other possibilities such as direct contact, migration, shared knowledge, or a common predecessor still need to be examined. If this common measurement seen at different places really came from an older source, the next question was what happened to it over time? This is where the analysis showed a pattern that took the story in a different direction. At Puma Punku, this measurement appears quite clear and precise. It can be identified more easily in the proportions of the blocks, grooves, and other dimensions. But when some other sites linked to later periods were examined, the same pattern did not appear as clearly. In some places, the measurements become more approximate. In others, the edges are more rounded. And in some cases, the same basic proportion is still there, but with less precision. A simple example can explain this. Imagine an ancient engineer developed a formula and taught it to the next generation. That generation used it but did not fully understand the technique behind it. Then they passed the same formula to their children. After several generations, the basic rule might survive, but the accuracy of using it could slowly decrease. If something similar happened here, it would appear opposite to our normal model of progress. We generally assume that knowledge increases over time, tools become better, and precision also improves. In other words, newer work should be more accurate than older work. But the pattern seen here appears to move in the opposite direction. Older examples show greater precision, while later examples appear less precise. It looks as if later builders were not developing a new technique, but were trying to repeat the remaining knowledge of an older technique. If this interpretation is correct, Puma Punku could be seen not as a beginning of an engineering tradition, but as a surviving part of that tradition. In other words, precision was not being created here. Previously existing knowledge may have been slowly disappearing. For now, this remains a hypothesis because decreasing precision alone cannot prove that lost technology was behind it. Different materials, different builders, and different requirements can also change accuracy. But if this trend is truly connected to time, then its source would have to be even older than Puma Punku. The alleged trend line tracing back 12,000 years. After this, the precision of sites linked to different time periods was viewed as a trend. When this trend line was extended backward, it appeared to reach a period around 12,000 years ago. That would be long before Tiwanaku, before writing began, and even before the period would normally connect. I preserved the wording as supplied and only removed the timestamps and bold formatting while arranging it into paragraphs.